Experiment 7 is about determination of the concentration of acetic acid in vinegar. The main objective of the experiment is to learn about titration as a technique to determine the amount of acetic acid in vinegar. Part A is about standardization of sodium hydroxide solution. So this is the stock solution that's already made up, and we are going to standardize this. So we're going to know exactly the concentration of sodium hydroxide in this solution. So because this is a base, we are going to use an acid that's already standardized, and that is going to be hydrochloric acid. This solution is already standardized, so take note of the significant figures. It's up to 3 significant figures. So the standard hydrochloric acid stock solution is 0.0930 molar hydrochloric acid. So now I took out about 150 ml or so of the standard hydrochloric acid, and I put it in this container. So I now label it as hydrochloric acid standard 0.0930 molar. I'm also going to take some sample from this container. Which is the sodium hydroxide that we want to measure exactly the concentration. And I'm gonna get about the same amount, about 150 or so. I don't have to exactly know the volume. Okay, so that is our solution that we want. Okay, so I labeled this as sodium hydroxide solution. So this is a glassware called a burette, and it's calibrated from 0 at the top ml, okay, and then it goes all the way to 50. So right, so up to 50 ml at the bottom. And there is a stopcock. So when the stopcock is straight up, it's open. If I close it like that, it's going to be perpendicular. Okay, so now I'm going to rinse this out with the solution. So we put sodium hydroxide in here. So basically we are going to do the technique of titration. So I'm setting this up, all right? So this is just my waste beaker. And I will use a funnel. And then I'm gonna pour the sodium hydroxide, all right? Okay. So put a little bit more. I want like about 5 ml. Okay. And I want to rinse this, so I basically just tilt it, okay, like that, to rinse the burette. Okay, and I want to let it go through the stopcock, and I don't want to see a leak. Okay, so you see that I don't have any bubbles and it's going through. So the tip, I don't see any air bubbles, and when I let it go through, it's smooth and I don't have any trapped air. Okay, so basically that's how we clean it. Okay, and now I'm gonna fill this up with that solution, which is sodium hydroxide, because this is salt, so I have to put it down. So again, a funnel, and then I'm gonna pour this up to the mark, which is 0, almost close to 0. Okay. So right now we're gonna read the initial volume. So you see that there's like an air gap here. So there's an air gap at the tip. So I'm gonna let it through. So I'm gonna redo, okay? Okay, so now I don't have any air gap. So we're gonna read the volume. Our initial volume is, so it's between 1 and 2. Write this down, please. Our initial volume this time is 1.40. So now I clamp it back. Okay, so I want the reading to be in front of me. So this is now our the stock standard hydrochloric acid, that's 0.093 molar, and I'm going to measure with this volumetric pipette. This is calibrated only up to, there's a mark here that is 25. So there's a mark below the A, letter A. There's a line, okay? And that means that that's 25 ml. So if I withdraw up to here, that's 25 ml. So I'm gonna use a bulb, okay, to suck it up. So I'm gonna immerse this into the solution, and I will press the bulb, and I will put it on top to measure 25 ml. You can see that I'm above the mark, right? Okay, so I have to release with my hand. So the pressure is coming from my hand, my left hand. And if I slightly release it, I release that liquid. So I want it right on top of that line. Okay, that's exactly 25 ml. And I'm gonna put it here. Okay, so I measured 25 ml of the hydrochloric acid. So that's our, I labeled it as 1. Run 1. So 25.0 ml is the volume of the hydrochloric acid. I'm going to do another run, and that's going to be our second run for the hydrochloric acid. So this is to deliver. So it's already measured. So there's a a little bit of a liquid in there, right? So I don't have to push it out because it's already measured, it's already included in the calibration. So I'm gonna do another one. Okay, so okay, I have to press the bulb so that I can withdraw or pull up the liquid up. Okay, so again, it's below the letter A, the mark over here. So I have to release my hand so that the lower meniscus is sitting right on top of that line. Okay, so 25 ml, and again, it's going to be on the second flask. So these are Erlenmeyer flasks or E flasks. So I'm using 25 ml each. So we're going to have 2 runs. And if the 2 runs are similar, we are going to just have 2 runs. Otherwise, we do another run. Okay. So we are doing the, so we're filling up this table. So the volume of hydrochloric acid used was 25.0 ml. And then initial volume of sodium hydroxide was 1.40 ml. Okay, that was the reading in the burette. That was the initial volume. Okay, so molarity of hydrochloric acid used was 0.0930 molar. So that one was 0.0930 m, and that goes to here. Okay, that's the concentration of the hydrochloric acid that we are using. Okay, so again, volume of HCl used is 25.0 ml. Initial volume of sodium hydroxide in the burette is 1.40 ml. So this one was the hydrochloric acid 25 ml. Okay, and I'm now going to react this. This is the acid, and then in the burette is the base, sodium hydroxide. So we are doing part A. So remember, we had the burette. I run the base to the stopcock. I fill up the burette with sodium hydroxide. We took the initial volume in the burette, and then I now have 25 ml of the pipette, and then I measure 25 ml of the standard hydrochloric acid solution. And now I'm going to add 2 drops of indicator to the flask. So this is the indicator, which is phenolphthalein, and I'm going to add 2 drops in this solution. So 2 drops of the indicator. So the indicator is clear. Okay, I'm going to add 2 drops. 1, 2. Okay. And then I'm going to put this solution under the burette, and I'm going to stir it. So this white thing here, the bottom is a stir bar. So we call it a stir bar. So the stir bar is a magnet. So this is a stir plate, and I'm stirring it. So I don't want it too fast. Okay. So I'm now going to add the base into the acid. I'm now going to start adding the sodium hydroxide, the base, into the acid. So if I start to add it, so I'm now adding it to, so you see actually that at the beginning there's really is nothing, we don't know what's going on, but I'm stirring it. Okay, there's the, you know, the stir bar. And if I add the base, you see that there's a slight coloration. Okay, so that's the indicator. Okay, so I'm gonna add. Okay, so there's a slight coloration, pink coloration. All right, so I'm gonna add more. So when do I stop adding? When there is a change in color. So if you don't add the indicator, you will not see anything. So I want the color to be very slightly pink and it stays. Otherwise, if I add and the color disappears, then that's not the end point. So we're looking for the end point. That's the when the amount of the base is now, in terms of the number of moles, is equal to the amount or number of moles of the acid in the flask. So we're shooting for a change in color that persists. So I can also rinse out the side just in case some of the base splash to the sides. I can rinse it with RO. It doesn't really change the result. Okay, and then I start adding again. Oh. So I have to adjust the drip to approximately a drop so that I don't overshoot the end point. So the volume is going down, as you can see in here. So now 24 right now. Okay, so you see that so when I put a drop, so I think we're close. We're getting close. So I have to add slowly a drop. I think one more. That's the end point. Okay, so that's the end point, and I'm gonna read. I'm reading it as 24.51. So 24.51 is the volume. 24.51, and that's gonna be your answer to this part. So the final volume of sodium hydroxide, is in here. So 24.51. Okay, so we are now doing the second trial, so trial 2 or run 2. Okay, so which is this part here. So again, the volume of the hydrochloric acid is 25.0 ml. And then the initial volume, I'm going to read. Okay, so write this down, please. The initial volume was the same as the previous one, so 24.51. So we ended at 24.51, right? So that's going to be our initial volume for the second one. So again, I'm going to add 2 drops of the indicator. So 1, 2, and then we're going to titrate again. So this is our second run. And again, Sodium hydroxide being added to the acid. So we want the 2 runs to be close as possible so we don't have to do a 3rd run. Otherwise, we have to do another run. So take note that this is only up to 50, so I have to watch that I don't go beyond 50. Otherwise, I have to stop it at 50, and then I have to add more sodium hydroxide. So I can now see some pink coloration when the base touches the acid. So it looks like we're almost there. So I'm gonna rinse out the tip and also the side of the flask. Okay, because sometimes it splashes. When the base touches the liquid, it would splash on the side, just to make sure everything is in the mixture. And now I'm gonna do it now, drop by drop, slower. So I think one more drop for that color to persist. Not yet, I think one more. Okay, so that's our end point, and I'm going to lower this down so I can read it. 47.70 is the volume. Results for Part A, standardization of sodium hydroxide, are shown in this slide. Molarity of hydrochloric acid used is 0.0930 molar. Results for Trial 1 are listed in this column. Volume of hydrochloric acid used in ml is 25.0 ml. It was converted into liter. It's now 0.025 liter. Initial volume of sodium hydroxide before titration in the burette is 1.40 ml. Final volume of sodium hydroxide after titration is 24.51 ml. The volume of sodium hydroxide used in ml is 23.11 ml, which is derived from final volume of sodium hydroxide minus initial volume of sodium hydroxide. So 24.51 minus 1.40 gives you 23.11 ml. This was converted into liter. It's now 0.02311 liter. Moles of hydrochloric acid used is going to be the volume in liter, 0.025 liter, times molarity, which is 0.0930 moles per liter, gives you moles of hydrochloric acid. That moles of hydrochloric acid is the same as the moles of sodium hydroxide because it's a 1:1 ratio in the reaction. Therefore, molarity of sodium hydroxide can be derived from the moles of sodium hydroxide, this value, over the volume of sodium hydroxide used, which is this liter. That gives you molarity of sodium hydroxide. You are going to do the same thing for trial 2, the same calculation. You will get 2 values of molarity. You get the average of that. So this value plus this value over 2 gives you average molarity. With the correct unit, it's going to be big M, capital M, or molarity, and 3 sig figs. Part B is now the titration of vinegar that we bought from the store, and we are going to be doing the same process. I fill up the burette with base, and then I'm going to now measure the vinegar, and this time you're just going to use 5 ml of vinegar, and I'm going to add 25 ml of water into the vinegar. And then again, I'm going to add 2 drops of the indicator. So our sample is distilled white vinegar, and it's diluted solution of acetic acid, and the label said it's 5% acidity. So again, it's 5% acidity. So this is our sample, the vinegar, and I'm just gonna pour this solution in here. So the same solution, okay? So I'm gonna put it back in here. And then that's gonna be our stock, okay? So I'm gonna measure using this pipette. So this pipette can measure 10, but I'm gonna withdraw up to 0, and then I'm gonna put in one flask 5, the other flask 5. So the same idea, I'm going to use the bulb and then withdraw the liquid. So I have to press several times. So the pressure makes it, it's like, you know, when you're using a straw, the pressure is coming from your mouth, kind of the same thing. And then I'm gonna use my left hand to control the flow of the liquid. So I have to withdraw above 0. And then slowly I release my hand. I'm controlling it with my left hand so that the lower meniscus is sitting right on 0. Okay? So now I press more, so because I don't want to release more, okay? So now I'm gonna put 5 ml in here. So 5 ml. So 5 ml, so lower meniscus again, just sitting right on top of that mark. Okay? Then I go to the next one, and then I'm gonna release it on 10. Okay, so it's right just above 10. Okay, all right, so done. So this is the remainder. So I'm just gonna measure using this volumetric pipette water. I'm gonna add 25 ml into that vinegar solution. So the mark of the 25, so there's really, this pipette doesn't have calibration in between, okay? So the mark is right there on top of the green. So that's 25.0 ml. Okay? Then I deliver it here. So again, this is to deliver. This pipette is to deliver. So I'm just adding water to dilute it. Okay? So that little remainder is already measured up. So then I'm gonna do one more. So that is our first sample. I'm gonna do one more to have a second run. So you press the bulb, same idea, and then okay, so I withdraw past that mark. So the mark is right on top of the green. Okay, so here, so this is the mark over here. So I slowly release my hand so that the liquid goes down, and then it's lower meniscus sitting right on the mark. And then I'm ready. So I added 25 ml of water, RO water. Titration of vinegar, part B. So fill up the brand, and then percent acetic acid and vinegar, molarity of sodium hydroxide used. This is going to be the answer from part A. So after you calculate this, the average molarity, okay? So let me go back here. So you're gonna determine the moles of hydrochloric acid, moles of sodium hydroxide, that's gonna be the same, and then molarity of sodium hydroxide. You're gonna take the average of these two, and that's gonna be the molarity or the concentration of your sodium hydroxide to the correct unit and significant figure. So show the calculation here for the molarity. So the answer here goes in this blank here. So now you have 3 lines filled up. Now the volume of vinegar, so we're doing trial 1, volume of vinegar is 5.00 ml. And then initial volume of sodium hydroxide, I'm going to read it. And then after titration is the final volume of sodium hydroxide. Basically, we're doing the same thing as part A, except the sample is now different. Instead of hydrochloric acid, it's now vinegar. Trial 1, this is the burette. So trial 1, our initial volume is 0.00 ml. Put back the burette in the stand, and I'm now doing sample 1 vinegar. So we do the same thing. I have a stir bar, it's stirring. However, I need to add 2 drops of the indicator, phenolphthalein, 2 drops. Okay. So in acidic solution, the indicator is clear, colorless. So now we're gonna add. So again, initial volume. So initial volume of the sodium hydroxide trial 1 is 0.00. So now we're gonna titrate, okay? So I'm now adding the base into the acid. Okay, I don't see yet any change or light pink coloration, so we continue. So right now, we know approximately that it's, so the percentage of the acetic acid in the vinegar is 5%. So it's not measured as molarity, but we're gonna figure out the concentration in molarity. We can always convert it to percent, but for now, we are going to measure the concentration of the acetic acid in vinegar in molarity. So there are different ways to express concentration, and one is percent, the other one is molarity, which is also the same as moles per liter. So I can see now some changes, so I better slow it down and rinse the side of the flask. So I collect all the base into the solution. So the color disappears, so not yet. So a few more drops. I think we're close to the end point. So the end point is when we added the number of, you call it equivalents of the base to the number of equivalents of the acid in your sample. I think that's the end point. So light, very light pink. gonna read it. So 43.15. 43.15 is the final volume. So take note that I'm sure of 43 and 1, but the final number or the last number is an estimate. So we have 4 significant figures for the burette. So 43.15. All right. So that is sample 1. I'm going to fill it up again because I need more than this much for the second sample. Okay. So the same thing. So we're gonna fill it up with sodium hydroxide as before, and then I have the funnel, and then I'm gonna pour the sodium hydroxide solution. So remember, we standardized this sodium hydroxide, so we know the concentration of this already based on part A. So I have this sodium hydroxide, but I put more, so I need to drain it up to 0. So I'm going to drain. So again, it's 0. So again, initial volume, so write this down please, second run. Initial volume of my sodium hydroxide is 0.00 ml. So now we are doing the last sample, which is sample 2. So again, the same thing, we have 5.00 ml of the vinegar solution with 25 ml water. So I'm now going to add phenolphthalein indicator, 2 drops. Okay. And we are now going to titrate again. This is our second run. And I'm going to lower this a little bit. The volume for the first one was about 43. So if it's close to 43, then we don't have to do a third run, okay? So now I can add it. Okay? So I can go fast. And then when it goes to around 42 or 41, I'm gonna go slow. So I can now see some pink coloration when it touches the liquid or the acid. And I'm going to rinse out the side and also the tip. So rinse out with RO water. So maybe one more drop. I think one more. Okay, that's it. So maybe we can rinse that out. Okay? Alright, so now we have gonna make it go higher. So we're now going to read the volume. The final volume is now, okay, so it's sitting right on 43. So 43.00. So 43.00 is the final volume. Results for part B, titration of vinegar. Write the brand of vinegar sample. Percent acetic acid in vinegar sample is 5%. Molarity of sodium hydroxide used is based on part A. Results for trial 1 are listed in this column. Volume of vinegar in ml is 5.00 ml. This was converted into liter. It's now 0.005 liter. Initial volume of sodium hydroxide before titration is 0.00 ml. Final volume of sodium hydroxide after titration is 43.15 ml. Therefore, the volume of sodium hydroxide used is 43.15 ml. This was converted into liter. It's now 0.04315 liter. The moles of sodium hydroxide can be determined from the volume in liter times the molarity of sodium hydroxide used. That moles of sodium hydroxide is now equal to the moles of acetic acid in vinegar. We can now determine molarity of acetic acid from the moles of acetic acid, this value, over the volume of acetic acid in liter, which is this volume. You're going to determine for trial 2 the same way as the calculations we did in trial 1. The mass of acetic acid and the percent mass per volume of acetic acid and percent error will be determined and shown in the next slide. So mass of acetic acid is equal to the moles of acetic acid times the molecular weight of acetic acid, which is 60 grams per mole. You get the weight of acetic acid or the mass of acetic acid by multiplying the moles and then the molecular weight. Then, to determine the percent mass over volume of acetic acid, the mass of acetic acid determined above over the volume in ml times 100% gives you percent mass over volume. You will have two values based on trial 1 and trial 2. Get the average of that two values and then you get the average. To determine percent error, the calculated percent mass over volume from the average, you subtract 5% over 5% because this is going to be the actual value from the label. This would be an absolute value. So if this is negative, it will be positive. And then times 100% gives you percent error.